Hi guys, this is Equilibrium 101 and this is part 2, and this is just a little bit more Keq Fun. And I wanted to start off with the law of mass action. And the law of mass action says that at equilibrium, the concentrations or pressures of the reactants and products is constant. Therefore, the ratio between them is also constant. So if we're looking at this in terms of math, and we use a general equation, so here's the general equation. We're going to have reaction between A and B, making C and D, and I spread those out for a reason. If we have reactant A and reactant B reacting to make product C and D, and these capital letters represent the substances, so these are the substance formulas. And then we attach to them a lowercase of the same letter. So little a, and little b, and little c, and little d, and those guys represent the coefficients in the balanced equation. So what the law of mass action says is that if we compare the concentration or the pressure of the products to the reactants, that's a constant number. So this constant value is found using the equilibrium constant expression. And so here's how it looks. So we get Keq is equal to the concentration of C, substance C, raised to the little c power. So that's the substance C, which is a product, and the concentration of that, and that concentration is raised to the little c power, times the concentration of D raised to the little d power, over concentration of A raised to the little a power times concentration of B raised to the little b power. Now, if this is all in terms of concentration, we would call this a Kc, where C stands for concentration in molarities. And so Kc is a type of Keq. So Keq is kind of an umbrella idea, and then a Kc is an example of a type of Keq. Okay, we can also put this in terms of partial pressures, where we have Keq can also be equal to the partial pressure of substance C raised to the little c power times the partial pressure of D raised to the little d power over the partial pressure of A raised to the little a power times the partial pressure of B raised to the little b power. And we would call this one a Kp. So P stands for pressure, of course. So we use this type of expression for an aqueous equilibrium, and this type of equation for a gas equilibrium. Okay, so a couple other things we want to remember is that Am I still on the page? No. Let's skip this back over here. That we only use aqueous and gases in our equilibrium expressions. Well, in our equilibrium constant expressions. So, if it's a solid or a liquid, you just mentally substitute a 1 into the expression. Because liquids don't have pressures or concentrations, solids don't have pressures or concentrations either. So we only use aqueous substances and gaseous substances in our equilibriums, or in our equilibrium constant expressions. So let me just give a really quick example here. We are going to practice to write the Keq expression for each reaction. And I'm going to take you through 3 examples because I heard examples are good, and I agree. And so you guys can pause as needed. I'm going to go on to my next page here. And let's say, for instance, that we're doing this first example where we have a gas equilibrium of N2 gas reacting with H2 gas is in equilibrium with 2NH3 gas. And I need a 3 right there. So we want to know what's the equilibrium constant expression for this reaction. And so we would answer with a different color because we like different colors. We would notice first that this is a gas equilibrium, so we're going to use a Kp expression. So therefore it's a Kp. So everything is going to be in terms of partial pressures. So we would have, we'd have Kp is equal to the partial pressure of the products raised to the power of their coefficients over the partial pressure of the reactants raised to their coefficients power. So we would have the partial pressure of NH3 raised to the second power over, and there's no other product here, there's no D, so to speak, right? So we would just have the one product on top. And then we'd have that over the partial pressure of N2 times the partial pressure of H2 raised to the third power. So that would be an example of a gas equilibrium. Okay, so that would be example 1. And then example 2, we can do like, let's say we have calcium hydroxide solid. Oop, there's a 2 there. And that's in equilibrium with the ionic calcium and 2 hydroxides. And those are both aqueous. This is a solid. So, since this is an aqueous situation, we would use a Kc. And we know we're going to do our products over our reactants, always. And this is going to be in terms of concentration. So we'll have Ca plus 2 times the concentration of the hydroxide raised to the second power, because this is a 2. And then we would go over the reactants, and then we want to recognize that this is a solid, So we would put this over 1, which obviously mathematically isn't going to make a big difference. Okay, so we've got our gas equilibrium and an aqueous equilibrium. And then we'll do one more equilibrium example. Let's say that we have, let's do NH3 aqueous reacting with liquid water. This is a classic acid-base reaction to make ammonium and hydroxide. And we want to know what's the Keq here. And we'll notice that this is aqueous, this is aqueous, this is aqueous. And so we're going to use a Kc expression because it's all aqueous. And we'll have the concentration of the ammonium times the concentration of the hydroxide. And of course, those are all raised to the first power because these coefficients are 1. And then we'd have that over the concentration of the NH3, also raised to the first power. And then the liquid water, we would just substitute a 1, which mathematically we wouldn't need to include. Okay, so those are our 3 examples of writing the Keq expressions for each of those reactions. And I think that is it for Equilibrium 101. Thank you very much. Hope you're having a good break and hope to see you guys soon. Okay, bye.